Chances are, if you've been around at all in 2023 or 2024, you already know about the hormones insulin, glucagon, and the drug Ozempic. What we're talking about in today's video is how exactly the hormones insulin and glucagon regulate glycolysis. Glycolysis is the metabolic pathway of burning sugar for energy. So right now, you're gonna learn exactly how insulin and glucagon hormone regulate and control glycolysis. This is part 2 of glycolysis. So see part 1 so you know exactly what is happening, what the frick is going on in your cell, and what exactly is glycolysis. Right now we are just jumping into how these hormones regulate glycolysis. First important thing to understand is there are 3 commitment steps to glycolysis. These are irreversible reactions, and these are the reactions that lock us into glycolysis. First irreversible step, the first commitment step, is when we go from glucose into glucose 6-phosphate. So this is by the enzyme hexokinase. Hexokinase uses magnesium as a cofactor. So this reaction literally doesn't work if you do not have magnesium there. And this reaction, this enzyme hexokinase, uses an ATP molecule to phosphorylate glucose on the 6th carbon. Hexokinase, glucose is a 6-carbon sugar, a hexose, and a kinase is an enzyme that does phosphorylation. So now we go from glucose to G6P. We know that this phosphate is ending up on the 6th carbon of glucose. This is a commitment step of glycolysis. It's the first step of glycolysis, and it's regulated by the hormones insulin and glucagon. Insulin will stimulate hexokinase, and glucagon will slow down hexokinase. What's insulin even doing when it's stimulating hexokinase? Imagine you just ate so much chocolate cake or a ton of ice cream or like literally just a bunch of bananas or a fruit smoothie. Now you have a ton of glucose in your cell, you have a ton of sugar in your body, and now insulin is being released. So your insulin levels are increasing as your blood glucose levels are increasing. Insulin, firstly, it's gonna show up at your cell and it's gonna trigger your cells to insert a GLUT4 receptor. This is like the little doorway for glucose to actually get into your cell. So insulin opens the door for glucose to get into your cell. Insulin's shoving glucose into your cell. Now that glucose is in your cell, hexokinase, this enzyme, is hanging out right there, and it is ready to phosphorylate glucose into G6P. Insulin activates hexokinase. So insulin's letting sugar into the cell, and it's activating this enzyme that's gonna start processing sugar in the pathway of glycolysis. Glucagon slows all of this down. So if we think about it logically, I guess, insulin is a hormone of energy abundance. It's when we have so much sugar, we want to burn that sugar and make energy. Glucagon is a hormone of energy gone, glucose gone. Glucagon shuts down this enzyme. It turns down this enzyme. So imagine that you have low blood glucose. You're gonna start slowing down the pathway that burns through your blood glucose. You want to conserve blood glucose. So insulin turns this up, glucagon turns this down. Glucagon is save sugar mode. Insulin is, we have so much sugar around our body, let's burn it, and make energy. The second enzymatic step that's regulated by hormones is this enzyme, Phosphofructokinase 1. What phosphofructokinase 1 does is it turns F6P into F16BP. Phosphofructokinase. So this is F6P, fructose 6-phosphate, and this is F16BP, fructose 1,6-bisphosphate. Phosphofructose, this is your phosphofructose kinase, an enzyme that adds a phosphate. PFK1 uses ATP to rip off a phosphate and stick it on to the first carbon of F6P and make F16BP. So here we have a fructose molecule with a phosphate on the 1 carbon and a phosphate on the 6th carbon. This enzyme, PFK1, is activated by insulin and shut down by glucagon. Those are how those two hormones are regulating PFK1. Last step of hormonal regulation in glycolysis is the enzyme pyruvate kinase. As you can already imagine, it is activated by insulin and it is downregulated by the hormone glucagon. So let's see what this enzyme is actually doing. Here we have phosphoenol pyruvate. Here we have the enzyme pyruvate kinase, and pyruvate kinase uses magnesium and potassium as a cofactor. So what that means is pyruvate kinase literally cannot do its job without magnesium or without potassium. And let's actually pay attention to this right here. PEP, phosphoenol pyruvate, has a negative charge here and a negative charge here. Well, I just said pyruvate kinase isn't going to work without Mg2+ or K+, magnesium or potassium. These stabilize the negative charge of this phosphate and this oxygen here. This is going to be stabilized in the active site of pyruvate kinase only when these minerals or ions are present. If these are not present, this cannot be stabilized in the active site, and this reaction is not going to go. So pyruvate kinase, with its cofactors, with its minerals, turns PEP into pyruvate, and then we also yield one ATP. So ADP, adenosine diphosphate, plus phosphoenol pyruvate, processed by pyruvate kinase, makes us one molecule of pyruvate and one molecule of ATP. This is the very last step of glycolysis, and this enzyme is activated by insulin and slowed down by glucagon. So there you go. Those are your hormonal regulations of glycolysis. Part 1 of burning sugar. And glycolysis is so ridiculously important because every single cell in your body needs ATP to function. ATP doesn't just show up out of nowhere. It has to come from something. What does ATP even come from? Pretty much it comes from sugar. You can also get ATP from fatty acids and amino acids, but burning sugar for energy is your body's most easily accessible, most favorable way to get the ATP that it needs to function. So part 1 taught you the exact metabolic pathway of glycolysis. This is what we covered in part 1. Part 2 taught you how your body controls glycolysis. These 2 videos are setting you up with everything that you need to know so you can better understand the tricarboxylic acid cycle and the electron transport chain. Both these processes are how your body makes a huge amount of energy. If you guys got any value out of this video whatsoever, like, comment, and subscribe. It helps me put more time, energy, and resources into making these videos, and ultimately I can make higher quality content for you guys. Okay, everybody, see you later, and have such a rocking day.